Thanks everyone for coming out. I wanted to present a project that I was recently working on that was meant to solve a lot of like the nitty-gritty, annoying stuff that I have to deal with on a day-to-day basis when it comes to making projects go live. So one of the gentlemen here asked me, what is a DSL? What does DSL stand for? It's a domain-specific language. So what I sought to do was write a custom language that could describe and solve the problems that I was facing on like a day-to-day basis. So this all began with a realization that I had. Oh, but this is the real one. Programming is fun, but deployment is not so much fun. When it comes to making a project go live, I found myself constantly running into the same things again and again. I would zip up the project, I would copy it remotely, I would SSH into the remote machine somewhere, unzip it, run a setup script, do a health check, and then repeat. And it got to the point where I just thought to myself, what if I could just automate all of this? So I thought about the problem a lot, and I came to a solution that had two main pieces. One is a background process running on the remote machine that would hook into native file system events, and then when a change event was fired, it would look at a file that was recently added, search for a zip file, unzip it, and then run a setup script. The reason you would need to have something remotely is because without it, you would have to do a lot of manual things. You would have to SSH directly in and run all the commands, which is something I'm sure many of you have already done, but I wanted to avoid doing it because I just thought it was a pain. And as a developer, I try to make my life as easy as possible and as lazy as possible, so that's kind of where this came from. The second part is the setup script itself, which is basically a list of instructions that would unbundle the project and get it up and running. So just real quickly, the daemon process itself, for it to be consistent, I thought that the best way to do it was to have a landing zone, something called a landing zone, a directory that was watched, and whenever a file was added, it would look for a zip file, unzip it, and then run the setup script. The setup script is where the DSL actually comes in, and it's where I decided to have a little fun. So this is the good stuff. Now, I could have easily placed a shell script into the package and called it a day, but I saw this as an opportunity to write my own language, and I took it for science. So why even do this at all? Why even like construct a DSL is because every project I would ever need to work on would require a different setup, a different environment, a different entry point. So why not come up with a way to abstract all of that away? So I came up with, this is a very simple language. Now, I'm not gonna spend time going into everything about the structure and implementation of computer programming languages, because there are literally entire libraries filled with things that I don't know. But what I do know for sure is that to transform any language to run on a machine, you need a compiler. So I wrote myself a toy compiler to make sure that this language ran and did what I wanted it to do. So just to take you through some of the basics. So Dave told me that a lot of you guys are mid-level and beyond, so I'm not going to spend too much time on like the nitty-gritty of what's going on. But every compiler has three basic parts. And you have the lexer, the parser, and the evaluator. The lexer is usually broken up into something called a scanner and a tokenizer. But depending on which distribution and which library or which compiler you're using, sometimes the things are merged together, sometimes they're not. I chose to write a separate scanner and a separate tokenizer, and I'll go into what these things actually do right now. So the scanner is what breaks the body of language into lexemes, which are the basic building blocks of a language's syntax. So just as an example, you have just a snippet from the setup script that I have, a task called task name, and then its commands. So the lexemes there would be just the string literal task name, a colon, a left parenthesis, a new line character, and then whatever the shell script was. The tokenizer reads each lexeme and adds metadata. And this metadata is what corresponds to the actual grammar of the language. And this is important because the form that a language takes and its structure are actually two different things. So I tried to come up with a good example for this. And so if I was to use the English sentence, I went to the store, English grammar would break it down as subject, verb, object. So if I was to break it up into lexemes, the lexemes would be I went and then to the store. Whereas the metadata attached to them would be I, comma, subject, went, comma, verb, and to the store, comma, object. So that's how you see the grammar tied to the individual lexemes. And this becomes important later on when you parse them into a meaningful structure, because the tokens don't actually have any meaning by themselves. They only have meaning in the context of other tokens. So there's this kind of like gestalt aspect to something that I found really cool when I was writing this. Now the parser is what provides that context. It takes the tokens and derives what programmers call semantic meaning. And without, I'm trying to throw as little jargon at you as possible, but basically, this is like what I was saying before, that each token can only have real value when interpreted in the context of other tokens. So the parser behaves more or less like a state machine, which is something I'm about to go into, but just to see. Now I totally understand if I just throw a bunch of code at you, like it won't really make any sense, so please feel free to ask me to clarify any of this stuff afterward. I'm trying to do the best to kind of tie together the project that I built and things that would make sense in the presentation. Now the state machine is what actually constructs the context, and this is an example of the state machine. Now there are third-party libraries that make a state graph, and basically why this is important is because you could have two different lexemes of the same type. Just to show you an example, if I was to go to the example of the language right here, like you'll see that task name and echo are both strings, but they have different meaning in that task name is declaring a task and echo is a component of a task. And the way you can differentiate that is through the state, whereas as the parser is parsing this file, the state changes when it encounters this left parenthesis. And that's just one example of how the state graph allows you to build a complex contextual structure from small building blocks. So the last part of this is the evaluator, which takes the syntax tree, which is right here, and evaluates it into actual meaningful code that can be run by the machine. Now, most compilers transform the language into native machine code. That much was overkill for what I was doing. I really just wanted a wrapper for shell scripts. So the evaluator takes this syntax tree and just runs it as a combination of shell scripts in order. And I'm going to show you an example of that right now. So, I'm not sure if you guys can see this. Can you guys see it? No? Okay. How about now? Tell me to stop. How many of you were able to see my slides? There, okay, that's okay. There we go. I was like, this is either really deep or people cannot understand what I'm saying. Okay. Well, if you have any questions, anything, I hope you can hear me at least. Please ask questions. But anyway, this is the setup script. You can see very simple syntax. You declare using the colon, and then you put the body of the declaration inside the curly brackets. You can invoke any task by using a semicolon. So this is a basic one where it just echoes 2 lines. It runs npm install, echoes another line. It runs a setup JS file, and then prints another line to the console. So let's see what actually happens here. Can you guys see the thing? All right, cool. Don't cheat. Here we go. Boom. Here we go. Now, npm failed because the package.json I don't think is valid. But what you can see is that it printed these lines to the console. And you see this line right here where it says it worked. This is actually a line inside the project, boom, which on its surface it's like, yeah, this is really simple, but this is something that could be uploaded to any machine anywhere in the world, and this script would be run without ever having to SSH into this machine, without ever having to do anything manually. The language and the compiler take care of all of this stuff for you. I managed to use this to great success, and it helped me be as lazy as possible when I was programming, which was great. So that is my entire process from beginning to end. So you might be asking, like, again, like, why would you do this? Well, one, of course, for fun. Two, you could say Docker could be used for something like this. And Docker, I'm a big fan of Docker. I use it at work and at home all the time. But I found Docker in production to be kind of unstable. The Docker daemon shuts down randomly sometimes. Once you opt into Docker, you opt into Docker Machine and Docker Compose and Docker Swarm and all this stuff, which isn't terrible, but it's also not a reason to completely ignore a side project like this, because you could run the daemon process right alongside Docker inside the container and have it do all the stuff that it already does. Shipit is another library I've used in the past. It's a JavaScript SSH client. You can do anything that you could do with normal SSH, but you still have to do it manually, which is something I was trying to avoid. And if there are others, please let me know. I'm always looking for ways to improve. Right now, sorry, there's still a couple things that I have to do to make this a complete project. One is having a proper recursive grammar. What that means is having a grammar that can refer to its own components. An example of this was if you were to define a task in terms of strings. String would be one component, and then a task declaration would be parenthesis plus string plus parenthesis, and that way it kind of refers to itself. That is something that every proper programming language has, and something that I'm probably going to build out at some point. Built-in commands. As I was using this, I kind of wished there was a way to set the environment just by using a command, like set the environment to node 5.4 or something like that. And lastly, a client to talk to the daemon process. That way you know whether everything has worked. Because if you have to SSH in to figure out everything happened, then it kind of defeats the entire purpose. But yeah, there's a lot more stuff to do. And if there's anything else that you think needs to be added, please fork the project or get in touch with me. I'd love to hear anything that you guys have to say. Here we go. Let's open the floor.
Just so people know, the name of the project
is Vuha. It's Vuha-daemon, but yeah, it's Vuha-daemon. Vuha is actually, it's a Sanskrit word that means formation, and it's kind of what those setup scripts are. It's like a loose, abstract definition of a project. So.
All right, everyone get up for.
Can I ask? All right,
question.
Have you thought about other potential applications for this type of new programming language that you're? Oh, yeah.
Totally. Well, it can be used for basically anything. So the language itself can be used to describe anything that you could break down into a series of tasks. The parser itself is geared toward bash commands, but that isn't something that's set in stone. Off the top of my head, could be anything from, I don't know, tallying up your budget, like what you're spending money on. It could be anything that you do on like a day-to-day basis, like shopping for groceries. You could, if you have like the IoT set up in your home, you could like turn on lights, stuff like that. Really, the sky's the limit. I mean, yeah, anything that you could break down into a series of commands you have to repeat over and over, this would be ideal for it.
So here at DSC, we actually use Docker to containerize our infrastructure and have immutable infrastructure and all that containers. And with your bad experience with Docker Compose and other ecosystem tools with Docker, like, have you turned away from the whole containerization approach entirely, or are you still on board with that and just using alternative tools to make it happen?
I don't think you can turn away from containerization because there's a lot more that containers do to stabilize and isolate a particular environment. Like Docker containers is an entire file system. This was to facilitate prototyping projects mainly. But if you're going to run a process inside a container, this would be ideal for that. So to answer your question, I would not turn away from Docker completely, but I would not use Docker to prototype. Doing that in the past has led to lots of frustration.
Is there any plan, do you have any integration with PM2 or any planned integration with PM2?
PM, like the process management?
Process manager tool?
That's a good question. PM2, so I've used Nodemon, like Node daemon. So PM2, I'm not sure. Does it hook into the file system for file system events?
No, it's just process management.
I mean, I could totally see some kind of like crossplay in the future. I haven't looked into PM2 in association with this yet.
So forks accepted.
Oh, totally. Please. It says it on the slide. No, but by all means, please get in touch. Please fork. What do you got to do?
All right, any last questions? Okay, give it up for Prakash.
Thank you.
I've been seeing a lot of rainbows lately, like everywhere, not just in opals, glitters, or those reflective signs, but when I squint my eyes, look at my hair, or glance out the window. For some reason, the more I find them, the more I am able to find them. It's weird how this works, this mysterious cycle of rainbow spotting. It does work though, and I'm sure of it because even now I can see it on my screen or on the edge of any of those lights. This is a place when I go to places like the Exploratorium